Checking the draft and excess air can tell an operator a lot about airflow conditions in a furnace. If the readings are normal, chances are pretty good that the draft and excess air are okay. But if the readings are not normal, adjusting the burner registers and the stack damper can often correct the situation. Some airflow problems, however, can't be solved by simple burner and stack damper adjustments. One fairly common problem is an air leak. If air leaks into a furnace, it can lower the temperature of the flue gases inside. An air leak can also lower the temperature of the tubes and the outlet temperature of the process fluid. If this happens, the temperature controller will call for more fuel to bring the outlet temperature back where it should be. Since more fuel is needed, the cost of operating the furnace goes up. An air leak can also throw off the excess air readings. For example, an air leak can cause the excess air value to increase. So a high excess air reading may mean that there's an air leak near where the reading's taken. Dark spots on the refractory could also be an indication of an air leak. Leaking air cools the refractory, making it appear darker than the hotter sections. A potentially dangerous airflow problem is insufficient airflow at the burners. If there's not enough air at the burners, some of the fuel sent to the furnace may not get burned. With unburned fuel in the furnace, you may notice that the firebox is hazy. Also, since the fuel is not burning completely, the outlet temperature of the process fluid could go down. If the outlet temperature goes down, the outlet temperature controller will trigger an increase in fuel flow to the burners, but this only aggravates the problem. If this extra fuel doesn't get burned, the outlet temperature is going to keep dropping. Besides the drop in outlet temperature, the insufficient airflow can lead to another problem. If air in the furnace reacts with the unburned fuel building up in the furnace, the fuel may ignite away from the burners. This ignition may produce a positive pressure in the firebox. The positive pressure further impedes airflow into the furnace, making the original airflow problem even worse. This could cause even more unburned fuel to accumulate in the furnace. In addition, the positive pressure may cause flames to shoot out of the edges of the peephole doors or other furnace openings. Also, the igniting of fuel away from the burners may produce a pulsing or thumping sound. If this airflow problem is not corrected, the burner flames could go out. Eventually, there may be so much fuel built up inside the furnace that if there is an ignition, it could literally blow the entire furnace apart. To correct this problem, first you may need to take manual control of the furnace and start cutting back on the fuel flow to the burners. When the fuel flow is reduced, the haze in the firebox should start to go away. Then the stack damper and the burner registers can be adjusted in small increments to meet the desired draft and excess air targets. A sudden rush of air into an air-starved furnace could cause an explosion, since there may be unburned fuel in a hot environment. We've just looked at airflow problems related to air leaks and to insufficient air at the burners. The next example is actually a combination of these two problems. It's called afterburning. Afterburning can occur when you have an air leak in the convection section at the same time that you have too little air at the burners. If there's not enough air at the burners, unburned fuel gets carried into the convection section. Then if you've got air leaking into this section, it can combine with the unburned fuel and ignite, which could cause a lot of damage. With afterburning, you may see smoke coming from the stack, as well as excessively high stack or convection section temperatures. And since afterburning is caused partly by insufficient air at the burners, you may notice an overly hazy appearance in the furnace. To deal with this problem, you may need to reduce fuel pressure until the hazy firebox clears. Then you can use the stack damper and the burner registers to start adding more air to the burners. In addition, if the afterburning is a result of an air leak in the convection section, the leak should be sealed up and the furnace repaired if necessary. In this part, we'll look at furnace fuel system problems. Fuel problems can arise when the flow of process fluid is significantly reduced and it's necessary to operate the furnace at a lower firing rate. At a reduced firing rate, it may be hard to supply enough fuel to the header to keep all the burners going. To avoid this, the operators may close off some of the burners and their registers so that no fuel is sent to them. When you shut off fuel to some of the burners, The fuel flow to the operating burners will be increased, reducing the risk of flameouts. Firing with fewer burners is a way of maintaining fuel pressure while satisfying the reduced demand. A problem that may occur in gas systems is freeze-ups in the fuel lines. In cold weather, condensation in the fuel can freeze and create problems for the operator. A knockout drum can remove most of the condensation, but a small amount may remain in the fuel that's sent to the furnace. In cold weather, even a small amount can cause a freeze-up. If you do have freeze-ups, you may find them in low points in the fuel system, where moisture can collect and freeze. If this happens, the fuel header pressure may decrease since the ice restricts flow in the fuel lines. Because of the reduced flow, eventually the process fluid outlet temperature will also decrease. In response, the fuel control valve opens up, trying to send more fuel to the burners. Some plants handle freeze-ups by injecting steam into the fuel lines while the furnace remains in operation. The steam thaws the ice. Abnormal conditions in a furnace include problems with the process fluid system. The tubes that carry the process fluid are a potential source of trouble. A common example of a tube problem is a hot spot. Hot spots are overheated areas of a tube. They may be caused by flame impingement or by insufficient process fluid flow. If there's impingement, the fix may be as simple as adjusting airflow to the burner to shorten the flame. If reduced process fluid flow causes a hot spot, increasing the flow rate through the affected tube often works. If there's more fluid moving through the tube, it will carry away more heat. Another way to handle a hot spot is to reduce the firing at that area in the furnace. If the burner closest to the hot spot is turned off, you'll direct less heat toward the problem tube. A hot spot may lead to coking, the buildup of carbon deposits inside the tubes. Coking can restrict fluid flow and cause heat transfer problems. Coking may be detected in multipass furnaces by comparing the flow rates through the passes. The flow rate will often be lower than normal through the restricted pass. The flow rate may have to be increased through that pass to equalize the flows through the furnace. Adjusting flow rates and firing rates are short-term solutions. They'll let you keep the furnace going temporarily until the problem can be fixed. But if there is a lot of coke built up in a tube, it should be removed. Many furnaces have decoking systems to remove the buildup from the tubes. This system injects steam and air through the tubes to remove the coke deposits and carry them out of the tubes. Another tube problem is a tube leak. When a tube ruptures, any flammable process fluid that escapes is likely to catch fire in the furnace. A high stack temperature is one sign of burning process fluid. Smoke coming from the stack is another. When there's a tube leak, you may also see smoke coming from the tube access doors. But if you do, don't open the door. The sudden rush of air could cause a flash fire. When there's a fire from a tube leak, the course of action will depend on the severity of the leak. If the leak is small, you may be able to keep the furnace going for a while. Also, in some cases, the leak will seal itself as coke forms around the hole in the tube. In many plants, the furnace is shut down and the fire is smothered with steam. With any fire, the operators will have to keep a close watch on furnace conditions and follow their unit's safe operating procedures. In this topic, we looked at several abnormal operating conditions in a furnace, including airflow problems, fuel system problems, and process fluid problems. To see